Join students. Today we are going to start with a new unit which is current electricity. Now students, electricity, it has a positive impact in our society. I mean, electricity is a source of energy, we all are aware of it, and most important thing about electricity is it is a controllable source of energy. So, it is found used in our homes, offices, industries, hospitals, and where not. Everywhere electricity is used. And all the electrical equipments which we make use of in our daily life are functional because of electricity only. Right? So, current electricity. It is, student, a branch of physics that deals with the electric charges which are in motion. So whenever the electric charges are in motion, then it constitutes electric current, right? Whenever the charges are in motion and they move in or tend to move in a particular direction inside a conductor, then it constitutes electric current. So in this unit, today we will be discussing only the intro part. We will discuss about charges, then type of charge carriers in solids, liquids as well as in gases. Then we will discuss about current, what actually current is. Then we will discuss about electric circuit. Without electric circuit, current would not flow, isn't it? So we will discuss about electric circuit, various electrical components will be discussed, and then we will also discuss the SI unit of current. There are some other units as well that also will be discussed, right, along with some numericals. And there are types of currents as well, right, that also we'll discuss. So let's start with the basic intro. So as I've stated, electric charges, whenever they are in motion and they tend to move in a particular direction inside a conductor, then only it will constitute electric current. Now, which charges I am talking about? Students, you must have heard about electrons. Yeah, the electrons which are present in the outermost shell of an atom. They are known as free electrons or the valence electrons. These electrons act as charge carriers inside a conductor. Right? What happens is, this is suppose a conductor. Let us consider this to be a conductor. Right? In case no source is applied, no battery is connected across its ends. So what happens is, these electrons means I am talking about only valence electrons or free electrons. Those electrons present in the outermost shell of an atom are known as free electrons or valence electrons. They only act as charge carriers. So in the absence of any source, in this conductor, no source is connected across its ends. So these electrons tend to move randomly about here and there. They do not have any particular direction of motion. They move randomly about here and there. So net motion of the electrons, I am talking about free electrons. Net motion of the free electrons inside a conductor in the absence of any source, that is zero. Net motion is zero. So here the net motion of electrons is zero. It won't constitute any current because the electrons inside the conductor are moving randomly about here and there. They do not have any specific particular direction of motion. Right? Now let's consider the other case. This is the same conductor. Now what happens is, its two ends are connected to a battery. Now student, this is a cell. The bigger line represents the positive terminal, which is at higher potential, and the smaller line that represents the negative terminal, which is at lower potential. And the combination of cells is known as battery. The combination of cells is known as battery. So this is a battery. This is a source. Here electrical energy is stored inside the battery in the form of chemical energy. So one of its terminal is positive terminal, the other one is negative terminal. So it acts as a source of potential difference, source of electrical energy, right? So we'll discuss about it in detail. So this is the positive end. So this will be at higher potential. I'll discuss about this term. HP stands for higher potential. Students will discuss about this term. And this negative, it stands for lower potential. It is lower potential. So, now what happens is, under the influence of the source, it is able to maintain a potential difference. Potential difference, in a sense, can be understood in this particular manner. Now look, you have heard about air current, you have heard about water current. Now when water flows or flowing water constitutes water current in reverse, isn't it? And when water flows from one place to another place only when there is pressure difference, isn't it? Air also flows from one place to another place when there is pressure difference. Similarly, heat always flows from one body to another body whenever there is temperature difference. So, what we can conclude is, for flowing heat, we require temperature difference. For flow of fluid, that is air or water, we require pressure difference. Similarly, students, for flowing of charge in a particular direction, electric pressure is required. And that electric pressure is known as electric potential difference. Right? We'll discuss the actual definition later on. But I hope you have understood what electric potential does or what's the role of potential difference. I again repeat, just try to understand this analogy. For the water to flow through a pipe, the pressure difference at the two ends of the pipe is a must. Similarly, for air to flow, pressure difference at the two places is a mandatory condition. For heat to flow, temperature difference is required because heat always flows from a body at higher temperature to the body at lower temperature, isn't it? So without temperature difference, heat won't flow. In this similar manner, for charge to flow in a particular direction, what is required? A sort of electric pressure is required. And that electric pressure which is required so as to maintain the flow of charge, that is known as potential difference. And students, that potential difference is provided by these two terminals of a cell or the combination of cells, which is known as a battery. So what this cell or what this potential difference does is, it makes the electrons to move in a particular direction. Now what happens is, in this case, all the electrons, which type of electrons? I am talking about free electrons. All the free electrons, which are the valence electrons, which are the electrons present in the outermost shell of an atom, they tend to drift, they tend to move in a particular direction, from one end of the conductor to the other end. And which direction it will move? It will move from negative terminal of the battery to the positive terminal, because it is at lower potential and it is at higher potential. So electrons moves along this direction. It will tend to move in a particular direction. So now charge flow does takes place through the conductor, and now the current is said to be constituted, isn't it? Here look, there is no source, there is no electric pressure between the ends of the conductor. So these electrons move randomly about here and there. There won't be any definite flow of charge. But here, under the influence of electric pressure, which is potential difference, the electrons tends to drift in a particular direction. And students, always remember, what is that particular direction? That particular direction of the movement of free electrons is from negative terminal to the positive terminal of the battery. And electrons, as you are aware, they are negatively charged particles, isn't it? Electrons are negatively charged, carrying charge of minus 1.6 into 10 raised to minus 19 coulomb, right? So now when the electrons, which are the charge carriers, moves inside a conductor in a particular direction, it is then current is said to be constituted. And suppose this is a cross section. This is the cross section of a conductor. So in this case, the charge flowing per unit time, that is, students, that is known as electric current. That is known as electric current. So current, its direction, the conventional current, I am talking about conventional current. Conventional current, its direction is always taken from positive terminal to negative terminal. And here in the electric circuit, you are supposed to indicate the direction of conventional current, not electronic current, right? This is the direction of conventional current, which is from positive terminal of the battery to the negative terminal, right? From positive terminal to the negative terminal, against the direction of the electronic current. Electrons are moving along this direction. The electrons are moving along this direction. Conventional current would be in the opposite direction. So in any electric circuit, you are supposed to indicate the direction of conventional current and not of electronic current, right? The direction of the flow of electrons is from negative terminal of the source to the positive terminal, while the direction of the conventional current is opposite to the direction of the flow of current. That is, the direction of conventional current is from positive terminal to negative terminal. Clear? And through this cross section, some charge will be crossing through this section. So the charge crossing per unit time through any cross section of a conductor, that gives the measure of the current. That gives the measure of the current. Right? So again, I must repeat before proceeding further. Look, electricity, students, it is a source of energy, and as I stated, it is a controllable source of energy. We can control electricity, so we can use it as per our convenience. So it has put a tremendous positive impact in the modern society. Whatever devices we are using, it makes use of electricity only, right? So it is one of the most important source of energy. Now, what I have discussed is, when electricity is said to be flowing, or when current is said to be flowing through a conductor, it is only when the charge carriers, which are the free electrons inside a conductor, tend to move in a particular direction. And the electric pressure, which is known as potential difference, which is provided by these two terminals of a battery, that helps the flow of charge inside a conductor. And the charge flowing through any cross section of a conductor per unit time, that is known as electric current. That is known as electric current, right? So, electric current, it is charge which is flowing through any cross section of a conductor per unit time. So do remember this. The charge flowing through any cross section of a conductor per unit time is known as electric current, right? So I, it is equal to Q by T. Q represents the charge. Now, if small charge, if dq charge flows through any cross section of a conductor in time dt, then in calculus I is given by dq by dt. This is in calculus. This obviously will be the instantaneous current, the differential coefficient of charge with respect to time. Anyway, coming back to this, regarding its SI unit, look, SI unit of current is ampere. It is after a French mathematician, André Marie Ampere, right? So its SI unit is ampere. Its SI unit is ampere. A-M-P-E-R. The SI unit of charge is coulomb. Again, it's after the name of a scientist. Coulomb. And time, we are aware it is second. So 1 ampere is equal to 1 coulomb divided by 1 second. So students, when the current flowing through a conductor is said to be 1 ampere, what will be the answer? The current flowing through a conductor is said to be 1 ampere when 1 coulomb of charge crosses through any section of a conductor in 1 second. I repeat, students, the current flowing through a conductor is said to be 1 ampere when a charge of 1 coulomb crosses any section of a conductor in 1 second. That is when the current flowing through the conductor is said to be 1 ampere. Right? There are some other units as well. There are some other units of current as well. Like there is electrostatic unit, there is electromagnetic unit. So these are the units which may be used in MCQs. So let's discuss about those units as well. Look, CGS, electrostatic unit. CGS electrostatic unit of current is stat ampere. And relation is 1 ampere is equal to 3 into 10 raised to 9 stat ampere. This is from numerical point of view, right? Then CGS, you are aware, this is a system of unit. Electromagnetic. CGS electromagnetic unit of current is ampere. And 1 ampere is equal to 1 by 10 ampere. So these are the two units which we make in CGS system, electrostatic and electromagnetic unit, right? There are some other units as well, like milliampere. It's 1 milliampere. It is 10 raised to minus 3 ampere. 1 microampere. It is 10 raised to minus 6 ampere. 1 picoampere. It is 10 raised to minus 12 ampere, and so on. So these are the units which we generally use to denote the current flowing through a conductor. Right? So students, electric current mathematically is defined as the charge flowing through any section of a conductor per unit time. That is electric current. And electric current will be constituted inside a conductor only if the charges are in motion in a particular direction. Right? Under the influence of electric pressure, which is known as potential difference. Okay, now what to do is, there are some various types of currents as well. There are some various types of current. And before that, before discussing the various types of currents, what to do is, we need to understand about the electric circuit as well. Can you define electric circuit, students? The continuous and the closed path of current is known as electric circuit. Like, let's discuss a simple electric circuit. Like this is a wire and a torch bulb or a small bulb is connected over here, and this is a source, a cell, and this is a key. This is a key, and this is the case of a closed key. This is a case of a closed key. So now what happens is, obviously, direction of the conventional current is from positive terminal to negative terminal. So current will flow through the filament of the bulb. So in this case, current will flow. So this is a continuous and closed path of the current. This is known as an electric circuit. So students, what is electric circuit? It is a continuous closed path of electric current. And this electric circuit may constitute various electrical components. Now, in addition to bulb, source and key, it may comprise of some measuring instruments like ammeter. It's a device to measure electric current. It can comprise voltmeter. It is used to measure potential difference. So it can contain various other electrical components as well. So any continuous closed path of electric current can be termed as an electric circuit. This is a closed key. That is when the circuit gets completed. Now in case a circuit is broken or the key is open, then current will become 0. There will be a discontinuity in the flow of current. So in this case, current flowing through the conductor would be 0. So in case of a closed key, current will flow. In case of an open key, current will not flow. Right? So that's electric circuit for you. Now students, we will discuss about various types of currents. There are various types of currents. Like, first type of current, it is direct current. A cell which we purchase from a shopkeeper from a market, that is a dry cell having positive negative terminal. So that is a source of direct current, right, which we make use of in torch lights or in remote controls or in toys. So that's a source of direct current, which we call as DC. So I'll try to make you understand through these graphs. I stands for the current, T stands for the time. Now this is direct current. What does it indicate, students? It indicates that with the passage of time, the magnitude of the direct current or the direction of the direct current remains same. So that current whose magnitude as well as direction remains constant, remains same, is known as direct current. Clear, students? So this is the first type of current. So what are the sources of direct current? Normal cell, dry cell, simple voltaic cell. These are the sources of direct current. Leclanche cell, Daniell cell, they all are the sources of direct current. Right? Second, variable direct current. Variable direct current. So again, consider the graph. This is current, this is time. It can be like this. What does this graph suggest? This graph suggests that the magnitude of the current is changing with the time. It is not constant, but it is unidirectional. Unidirectional means in the same direction, but its magnitude is constant. So variable. So that current whose magnitude varies but is unidirectional, that is flowing in the same direction, that is known as variable direct current. Right? Third, this is very, very important. This is AC, that is alternating current. Alternating current. It is known as AC. Now look, this is suppose alternating current and this is time. It is of sinusoidal nature, like this. It is of sinusoidal nature. It can be represented either by sine function or by cosine function. Right? So basically we will deal with this topic in the subsequent chapter. So this is alternating current. Its source is AC generator. Right? In dams, hydroelectric or nuclear power stations, AC current is produced. Right? In homes, offices, industries, shops, schools, the current which flows is the alternating current. We prefer this particular current because it is much more economical to produce. It is very, very economical to produce. So, what about this current? Look, it is that current whose magnitude changes continuously. With the passage of time, its magnitude changes continuously. It is never constant. So, its magnitude should change continuously. Along with that, another important property is that it reverses direction periodically. After definite fixed interval time, it tends to reverse its direction. This is positive half, this is negative half. Again, this is positive half, again, this will be negative half. So, alternating current is that current whose magnitude changes continuously with time and it reverses its direction periodically. That is, after every fixed interval of time. So, such a current is known as alternating current. There is another current also, fourth type of current, that is known as transient current. It is known as transient current. Now look, students, it is also a sort of DC only. It is that current when the circuit is closed, when the circuit is switched on, then the current doesn't abruptly grows to maximum value. It takes some finite time to grow from 0 to maximum value, right? It will take some finite time to grow from 0 to maximum. And then if the switch is kept pressed, after some time it will attain steady value. It will attain steady value. From this to this, it is the case of direct current. And then when the circuit is switched off, it will not abruptly, the current will not abruptly or suddenly become 0. Instead, even after switching off the circuit, the current will take some finite time to decay from maximum to 0 value. It will take some finite time to decay from maximum to 0 value. So this is the time T1, which is the time taken during the growth of current. This is the time T2 during which the current remains steady or constant. It is the case of DC. And T3 is the time interval during which the current decays from maximum to zero value. So students, transient current is that current which takes some finite time to grow from zero to maximum value, as well as it takes some finite time to decay from maximum to zero value. So that is known as a transient current, right? So these are the four different types of currents. Now next is we can proceed with the various types of charge carriers. Now look students, there are solids, there are liquids, there are gases. In solids, as I have stated, in solids, the charge carriers are the free electrons. And free electrons, students, as I have told you, these are the valence electrons which are present in the outermost shell of an atom. So in conductors, the charge carriers are the electrons. Which electrons? Valence electrons, which are present in the outermost shell of an atom. So always remember, in conductors like copper, aluminium, iron, silver, these all are very good conductors of electricity, having large number of free charge carriers, which are free electrons. So the charge carriers in conductors are free electrons, right? Which are known as valence electrons. They are the free electrons, which are free to move about here and there inside a conductor. In liquids, the charge carriers are ions. They can be cations or anions, right? So there are certain liquids which, when current is passed through it, they tend to dissociate itself into ions. And such liquids are known as electrolytes. So the charge carriers in liquids are ions, right? So a normal atom, that is electrically neutral. So when an electron is extracted from it, then the remaining atom becomes positive ion, right? So ion causes some charge, either positive or negative. Accordingly, it is known as anion or cation, right? So in liquids, ions act as a charge carriers. Here I must state, mercury is the only example of a liquid which conducts current due to the presence of free electrons. Remember students, mercury is the only liquid, it is an exceptional case. Mercury is the only liquid which conducts current due to the presence of free electrons. All the other liquids which conducts electricity are due to the presence of ions, right? So remember this. Third, in gases. Gases normally they are poor conductors of electricity, but at extremely low pressure, the gases may get ionized and then it starts conducting current. So in gases also, the current is due to the ions. So these are the different charge carriers, electrons and ions. There are other charge carriers as well, which we will discuss in the subsequent chapters. In semiconductors, another charge carriers are holes, right? That we will discuss it in the later section. So these are the charge carriers in solids and liquids and gases, right? Now, before we conclude this session, we can try to attempt some simple. Okay students, let's attempt these two questions, right? Let's try to find out the solution of the first question. How many electrons will constitute a charge of 1 coulomb? Now look, an electron carries a charge given by 1.6 into 10 raised to the minus 19 coulomb. Obviously, the nature of the charge is negative, but magnitude wise it carries a charge of 1.6 into 10 raised to the minus 19 coulomb. An electron carries this much charge, obviously negative, right? It carries negative charge. Now suppose n electrons collectively constitute a charge of 1 coulomb. Then total charge constituted by n electrons, single charge will constitute this much charge, right? So therefore n electrons will constitute a charge of q, that will be given by n times the charge composed or consisting by 1 electron. So therefore number of electrons that will constitute a charge of 1 coulomb would be q by e. So 1 net charge is 1 coulomb and charge carried by each electron 1.6 into 10 raised to minus 19. So we can easily solve it. So it will be 10 by 16 and 10 raised to 19. So it can be written as 100 by 16 into 10 raised to 18. So 100 by 16, it will give us 9640, 16 2 32 80, 16.80. So it will be 6.25 into 10 raised to 18. So students, this is a very important result. Do remember this result. So 6.25 into 10 raised to 18 electrons together will constitute a charge of 1 coulomb. Right? So 1 coulomb is a large unit of charge. So these electrons collectively will constitute a charge of 1 coulomb. Right? So that's solution for question number 1. Let's discuss the second question. It's a very basic fundamental question, right? A current of 10 ampere flows through the filament of a bulb for 5 minutes. Find the charge through the circuit. So this is a circuit and current of 10 ampere is flowing, and this is a bulb and it flows for a time of 5 minutes. Now students, we are aware current is said to be flowing through a conductor when charge crosses through any section of a conductor per unit time, isn't it? So current actually is the rate of flow of charge, or current is defined as the charge flowing through any cross section of a conductor per unit time. So Q is to be determined, so it will be equal to I into T. So Q would be equal to current flowing through the circuit is 10 ampere. Time is 5 minutes. Now don't forget to convert this minute into seconds, because we need to express the charge in coulomb, which is the SI unit, and in SI system time is to be written in seconds. So 1 minute is 60 seconds, so time would be 5 into 60. So it will be 10 multiplied by 300, so it will be 3000 coulomb, or it may be written as 3 into 10 raised to power 3 coulomb. Right? So that's the solution for question number 2. So these are some very basic questions, right? I hope you have understood all the basic concepts in this unit of current electricity. Now in the subsequent sessions, we'll discuss more and more advanced topics. So students, again, I will advise you to be very regular and particular about your studies. And I must again say, please, if possible, try to share the link of my YouTube channel with your colleagues, and if you find the way in which I teach to be very beneficial to you, then please recommend to your colleagues and to your friends as well. And don't forget to hit the like button. Thank you.